Our Earth disposes of several fossil fuels, such as oil, the most common resource used for transportation, or coal, which is mostly used in the industrial sector. However, there is another type of fuel which we use on a daily basis to produce energy in power plants or even to heat up our own houses. We are talking about natural gas. Fossilized natural gas can be found in deposits, and it is produced from anaerobic decomposition of organic material. It is mostly composed of methane, the smallest out of all hydrocarbon molecules. However, it can contain also ethane, propane, and butane, as well as small quantities of pentane. There are many gas fields, and they are present almost all over the globe.
The largest supplier is the country of Russia,
with a staggering yearly production of 62,461 cubic gigameters of natural gas. According to a 2010 estimate, its reserves will last at least for another 74 years. In second place, we find Iran and Qatar, with a yearly production that ranges between 120 and 150 cubic gigameters. Let's look at how natural gas is extracted. Most of the times, natural gas is located in the presence of a coal field. This happens because over the years of decomposition of organic material caused the formation of layers of peat in river and torrential areas. Coal and natural gas are generated through fossilization of peat layers. Before starting with the extraction, it is necessary to carry out inspections on the territory in order to determine the size of the field, the amount of gas present, and the feasibility of the process of extraction. Geologists and geophysicists carry out tests on the reservoir site to digitally recreate the subsoil in 3D using a technique called seismic reflection, a sort of scan of the oil. This technique consists of firing seismic waves which, reflecting on the underlying claying layers, are able to geographically reproduce the subsoil, highlighting potential natural gas deposits. After this initial procedure, we continue by drilling an exploration well to make sure that the gas is present in this area. Subsequently, other types of wells are drilled, called delimitation wells. These have the function to delimit both vertically and horizontally the effective extent of the gas field, in order to have a precise assessment of the amount of gas. This is to ensure a fair economic return to the company that invests in the particular field. Once the quantity of gas that the field contains has been verified, we move on to the next step, which consists of drawing up a developmental plan. The developmental plan will decide how many extraction wells have to be drilled on the site, in which position, with which trajectory, the type of well, vertical, horizontal, or deviated, as well as the position and number of structures necessary for the management and transport of the extracted gas. The type of the structure built to extract the gas can vary depending on the location of the field. When the reservoir is close enough to the Earth's surface, the construction of the site and the gas extraction are easier. However, sometimes the deposit may be located under the seabed. In this case, the preparation of the site is more complex. It is necessary to build a platform in the middle of the sea, an offshore platform, from which all drilling and extraction operations can be managed. Whether on land or at sea, the drilling procedure is very similar. Let's now examine the structures and steps necessary for the extraction of natural gas. To drill the soil, we use a special tool which resembles a rotary chisel. This chisel is composed of 3 conical heads made out of a very hard material, able to crush and shatter the soil. The chisel is attached to some 12 to 15 meter long rods, which are inserted as the excavation progresses. This machine is held together by a hook with steel wires connected to a system of pulleys that enables the drilling device to raise and lower. To give energy to all of the instrumentation, we use an engine connected to a winch. The engine will also make the rotary table start rotating and therefore to drill. The rods brought down through the drilling are hollow, and inside them flows a special mud that, in addition to lubricating the chisel, brings up the debris left by the crushing process. The excavation mud is brought to the surface through the pipes and is released into a tank, where it is filtered and then separated from the debris. The mud is then reintroduced into the rig, specifically to avoid landslides that could damage the tools. As the drill digs, the walls of the well are lined with steel pipes and cemented to the ground. Furthermore, the head of the drill is replaced with similar and smaller ones as the excavations proceeds. It starts from a 70 centimeter diameter to a diameter of about 10 centimeters, and the wells can reach a depth between 2 and 6 kilometers. At those depths, the pressure is very high, which is why a special valve called wellhead, or more commonly, the Christmas tree, is used. This equipment is a set of valves that control the pressure exerted by the gas rising to the surface. Once the digging phase is complete, the drill is removed and the extraction of natural gas from its field can begin. The gas, brought to the surface by a system of pipes, is conducted into treatment tanks in order to be prepared for diffusion on the several predetermined points. In nature, gases comprise mainly of methane, and it is an odorless substance. Thus, to ensure that it is perceived when there is a leak, peculiar substances are added to give it a strangely unpleasant odor. In some industrial plants, odorless natural gas is used because there are sensors that identify leaks of dangerous substances. Once the treatment process is finished, the gas can be sorted into the various established areas. So-called gas pipelines are used to distribute the product in houses, factories, but also in power plants for production of electricity. Similarly to oil, gas is a limited fossil fuel. Actually, the reserves on the planet can still be exploited for many years, but fuel consumption has increased dramatically. This is why, in recent years, new alternative techniques have been developed to be able to produce natural gas, such as the production of biogas, which is obtained directly from the decomposition of organic waste, or with the extraction of methane from manure produced by animal farms. The technology to produce biogas exploits the formation of bacteria inside special fermenters. In this way, urban organic waste, manure, and agricultural waste can be transformed into gas. For instance, 5,500 cubic centimeters of biogas can be obtained from a landfill of 1 million cubic meters. In a world where the consumption of fossil fuels is undergoing an exponential growth, can these new production elements represent a solution to a more sustainable society? If you find this video useful, let us know by leaving a like and a comment below. You can also share it. And don't forget to subscribe to our channel. We invite you to click on our website, jawscompany.com, to know more about our next projects.